Hello, YouTubers. Today I'm going to talk to you about a very interesting technology that Microsoft introduced in .NET Conf, maybe a few months before that even, which is machine learning. Bringing machine learning to mainstream developers through a really rich bundle of libraries that, tackle every possible problem you might need machine learning to tackle. ML.NET is a very interesting, easy to use bundle of libraries that doesn't require you to know too much about machine learning. You don't have to know a lot about the algorithms that are involved in machine learning, but you could still bring that to your application if you know what you're trying to solve. So the only problem really is knowing what algorithms ML.NET is trying to offer and whether it fits your solution or not. The rest is just integration that I'm going to show you to do today, how you can accomplish that in like probably 20 lines of code, maybe less. So let's jump to our solution here real quick, just to show you things in action. And let's create a new console application, console.NET Core. And I don't even need to do that. I have an empty solution open right here, so I'm just gonna create a new project, and let's call our project ML is awesome console application. All right, so here's the problem that we're trying to tackle before we jump into the writing the code in OneNote. Let's say you have a bank account, and your bank account has some withdrawals that happen out of your bank account every day, right? And you want to be able to detect if an unusual withdrawal happened from your bank account. You don't want to get a notification for every withdrawal that happened, but if some weird, not usual withdrawal happened, you want to be able to be notified. So there's a couple of things here. You can't really put, if you go and say, I want to put a maximum limit if my bank account withdrawals exceed that level, that amount, then notify me. I guess that might be a good idea, but you need somehow to know what is your regular or average spending limit so you can put that number. So somehow you want a machine to study your regular daily spending and then generate that number, that magic number, that if it exceeds that magic number, it will immediately send you an alert and say, this is a weird withdrawal, this is a weird amount, I don't think you did that, your account might have been hacked, or something like that. How do you resemble that in a software? How do you solve that problem using ML.NET? So this is just a very simple console application. Here's a zoom in for people who are doing this on the phones. And let's just go ahead and install a NuGet package. If you type in ml.net like this, you will see all these different libraries, ml.net libraries, that tackle different problems. There's one for image analytics. You show it a bunch of dogs, and then you show it a cat, and it said, nope, that's not a dog, that's a cat. You have to train it on some data and then use it. There's CPU math, there's FastTree, there's all these different kinds of libraries that are super rich and very, very, very useful. The one that we're going to work with today is something called Machine Learning Microsoft ML.Time Series. So time series, you have on daily basis, there are withdrawals that are happening from your bank account, and you want to be able to detect the irregular or unusual activity on your bank account. So I'm going to install this library here real quick. And here's my library. Accept. And then I'm going to go ahead and create a couple of models, right? The first model I want to create is the withdrawal model, right? If you can model and simulate your problems from real life into a computer, you can solve any problem you could think of. So here's a withdrawal, and this is my the activity of withdrawal. I'm just going to define that as a float, and it's the amount. So every time there is a withdrawal, there's an amount, right? So the amount of the withdrawal, that model will resemble that. But I also want another model in here that I'm going to call prediction. This is where the machine learning algorithm, what the machine learning algorithm is going to use to put in the results that I need to see. The results that I really care about is what is the original withdrawal amount, whether it's an anomaly or not, and how confident the algorithm is about that prediction. So let's put in here something, let's call it a value type. So it's a double array because it's three different values, right? Three different values that are going to be like, every prediction that we're going to release, it's going to contain an array of three values. You know, the values I just told you about, the actual amount, the prediction percentage, and the confidence percentage, and whether something is an anomaly or not. So let's call this guy, I don't know, let's call it output. I think output is a good enough name, right? And then there is one little thing I need to add on top of this, which is an annotation that say this is a vector type. This is how this algorithm is going to know this is the type that I want to deal with. This is my output type, and this is what I'm going to do with it. All right. With that being said, let's start from scratch. We talked about a series of withdrawals that happen from your bank account, right? So let's just create a series of some random numbers that we're going to put in there with the little hint of putting something unusual in there. So I'm just going to go in here and say, here is an array of numbers, right? And this array has, let's say there is 100, there is 150, there is 200, there is 300, and then there is, let's say, 250, and then all of a sudden there's $3,000 that got withdrawn from your bank account, and then everything else went the same for the rest of the rest of the series. So there's another 100, there is 100, there's maybe 250 in here, there's 300, and so on and so forth, right? So the process just kept going forward until there's something unusual that happened in the middle of that series, right? So this is numbers, right? Now let's call it amounts. I like amount more. Amounts. That's amounts of money that got withdrawn from your bank account over a series of time. Now let's convert these amounts, this array, into an array of withdrawals. It's very simple, really simple C# stuff. If I say list of withdrawals, bring in the libraries, control period, and then here's my withdrawals. And then I'm gonna say these amounts dot select. So select is the equivalent of map, right? I'm mapping things from one type to the other on a collection level, right? So amount is basically an amount. Here's an expression, and then I'm gonna go and say for every amount in these amounts, create a new withdrawal object and set the amount to equal the amount, right? And make sure all of this thing is converted to, let's take a new line here so people can read, to list, right? So there's no magic there. I just created a random list of withdrawals that happen from some bank account, right? The next step is we're gonna play with machine learning. So the first thing you want to do is you want to create the machine learning context. The machine learning context. The machine learning context is very simple. You say var machine learning context equal new ML context. That's machine learning, and then we're gonna go here and do control period, pull that context, pull the namespace, the library, and then instantiate that. So far so good. I'm just instantiating my machine learning context. The next thing I want to do is to select which algorithm I'm going to use to calculate that anomaly. To calculate, that weird, to calculate all these transactions and tell me which one is anomaly. So just to declare that algorithm, we're just gonna go here and say var estimator equal, and then I'm gonna use my machine learning context, and then I'm gonna say transforms, and then there is so many algorithms that you could use here. There's detect anomaly by SRCNN, detect change point by SSA. You have all these different ones. The one that we're going to use today is something called detect IID spike. IID stands for independent identically distributed on a time series. So distributed points, identically distributed across a time series. We're going to use this guy, detect IID spike. You should play with the other algorithms, and maybe I will make more videos about, what these other algorithms are doing. For the time being, let's see what this guy wants from us. We're building the algorithm and we're building the output of the algorithm. I'm telling the algorithm, here's my input, field. Here's my output field and my confidence, and then the history that I want you to look at. So the first thing I want to do here, if you do Control Shift Space, it'll tell you what you need to insert. Since this is not pretty straightforward, I highly recommend using the aliases of the input parameters for this method. So output column name, I'm just gonna go here and say name of, and then I'm gonna say my output is my prediction model, specifically the output property on my prediction model, which is this guy here, right here. Right, this is the guy that I am assigning to be where all these three fields that this algorithm is going to produce to be put in. The second thing in here is my input column name, and my input is basically the withdrawals. So the name is here is the withdrawals dot amount. All right, so far so good. The next thing is something really important that you want to play with and see how the algorithm works, which you declaring what is the confidence level that you want this algorithm to use. The confidence level that you want the algorithm to use to determine which one is the anomaly. Some people go 95, I'm gonna go 99 to be really sure. If you put it to 100, it'll never give you any value, because these algorithms are based on, you know, calculus and analytics. You don't have that absolute value 100%. You know, you might. I tried it multiple times. I don't think you can actually reach that. The last thing we want to put is the p-value history length, which is basically when you give this. So focus with me here. If you give this algorithm instantiation or creation an array, it wants you to tell it how much length is a sample that it could take to train itself on. Right? So I want to give it half of it. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. So at like 3 or 4, it'll say this here is my sample of data that I'm gonna use to train myself that what is a regular value for you. What is a regular value for you? So I'm gonna go in here and say just give it half. So it's amounts.length.half. So by half. So that means half of this array, half of it, is enough data for this algorithm to take a look at. And that's important, because if you have millions of records that you want this algorithm to study, it doesn't make sense that you give it like 500,000, you know, just give it like, I don't know, 1,000, maybe 2,000, let it train itself on that data, you know, let it learn about all the possible regular values before you actually push a new array to it that has an anomaly. So right, so with that being said, let's move on to the next thing. We want to take our data. I'm going to build a data view, and then I'm going to say amounts data. So right now this guy doesn't know really anything about my withdrawals. I just instantiated my algorithm and I told it what's the sample and what the output should look like, but there is no connection between this algorithm creation or instantiation and your actual data. So somehow we want to link them together. This guy doesn't understand IEnumerables really. It understands something called iDataView, and I'm going to tell you now what we're going to do with this iDataView in a second. So back to the machine learning context data, and then load enumerable. You will notice before I do that, you will notice that all the load in here, it says load from binary, load from IEnumerable, load from SVM light file. It even create database loader. It gives you that the developers of this library, and I couldn't really appreciate it more, they gave you a whole bunch of options, several options for you to be able to use to load that data, right? You want to load your data from the database? Great. You want to load it from a file? Great. You want to load it from wherever you want, even a text file on your computer? Go for it. It's trying to make your life easier, trying to bring machine learning to mainstream developers. So for our case here, we're just going to load from enumerable. Our enumerable here are the withdrawals, so we're just going to set the withdrawals as an input parameter. Great, right? Now we want to link this guy, this estimator guy, to our data, to the amounts of data that we worked with. What are we going to do about that? So in here, I'm just going to create another data view, transformed amounts data. right? And in here, I'm going to say the estimator fit in that data, the amounts data, in your algorithm, and then transform that data to a data view here. So fit in the data and then transform that data into, amounts data, into a data view. Obviously, these libraries have just been worked on and developed very recently. Someone might say, why do we need to pass it in here? Why can't we just do it like that? I'd say you have a good point. You definitely have a good point. That's a thing that we could think about and make it better, you know, a point of improvement, but still doesn't really take away from the awesomeness that this library is doing. So we're just going to pass it in again, even though ideally for C# opinionated developers, they might have a little bit of a heartburn over that one. So right, so we created an algorithm, we created data, we put in the data to the algorithm. The last thing we want to do is just to output, you know, to print out what's going on with this. In order for us to do that, we want to list, because I can't iterate over a data view, so I want to convert it into something enumerable that I could work with. So let's just build a list of prediction. Since the prediction is my output, like we defined in here, your output column is prediction.output. So I'm just going to build a list of predictions, converting the existing list that this algorithm has spit out into something that I can iterate on and print out. So I'm just going to go here and say, again, the machine learning context dot data, create enumerable. This one is different, so I'm not loading, I'm creating enumerable out of iData view, right? Let's take that also in a new line so people could see everything. The iData view I want in here is transformed amount data. And the second thing here is just one object. It says reuse row object. It basically says whether to return the same object on every row or allocate a new one per row. I mean, I'd like for it to allocate a new one per row. So let's just say false. Actually, you know, from a usability standpoint, best practice standpoint, don't just pass a false or a true. Just, you know, mention if it's not already defined in a variable, just go ahead and do your due diligence and mention the alias, okay? Now, with that being said, I want to add toList so I can convert whatever comes out of this guy into a list of predictions. I want to identify the type in here, so it's prediction. All said and done. So this is now great. You know, this guy is returning. I don't even know, do I really need to do toList? Do I need to? Yeah, I guess. So let's do toList in here. All right, so now I have my results. Now I have my results. I'm gonna even break it down for you. So when I push that code, you know, like create data, create some data, right? And then in here, instantiate machine learning context, right? And then in here, create your algorithm. And then all the way down here, link data to algorithm. And then down all the way here, we want to say create output. So we're creating our output. Now let's go ahead and iterate. Let's iterate over that data, right? So I'm just going to go in here and say for each prediction in predictions, let's print out whatever is in that prediction object, right? So here is some string interpolation. Let me define things for you here real quick. So I have a double. It's an array of doubles, right? So the first thing I want to do is anomaly. I don't know if I'm spelling that right. So is anomaly, and then it would be the prediction.output predication. I wrote predication. There you go. Prediction.output. So this is the first member of the array, of the double array, because remember we said this is a double array. The second thing I want to do here is the value, right? So original value equal prediction dot output. So this is the original value. And then here confidence level I could go here and say prediction.output 2. So here you go. You have, is it an anomaly, original value, confidence level, and then let's print that out. So what do I want? I want to print my original value, right? And then /t to take a tap, and then I want to say here the confidence level of the algorithm, and then another tap, and then I want to add in here whether it's an anomaly or not. So this is how I want to print this out, and then at the end here I'm going to say console.readKey just to hold off the console screen. So here you go. How many lines are these? We started at 14 and we ended up at 47, you know, give or take, you know, just around 30 lines of code or so. So it's not too bad. It's not too bad. So let's run our stuff. Let's run this application and see if things work. So I'm going to run my application here real quick. Here you go. Let's see if I can zoom that in for you so you can see things better. So look at this. So what's happening here is that you will notice that it's printing out when it saw 3000. It said, that's an unusual value. That's an unusual value. I'll even show you if we increase the sample of data, it will even be better. Let's increase the sample of data. If I put in here something like 250, because I think that when it did the division, it really discarded the value of 300 and thought of it as an anomaly. Let's run this again. I bet you it look at the 300 now and say, no, this value is all right. Yeah, absolutely right. So because the window that we defined did not include all these good values. So here's my window right here. Look at this. So it says for 100, I think that's not an anomaly, not an anomaly, not an anomaly. And then it went to 3000 and said, oh, that value is not normal. This is a spike in your data that you need to pay attention to. This is not the regular progression of data that you're using. So that's pretty much it. You know, if you're doing this, you can so easily implement machine learning in your day-to-day development work. There's so many different aspects of it, but I really highly recommend, like, someone might tell me, you know, I'm building, you know, an ASP.NET Core API, right? And I don't see how I'm going to implement machine learning in my API. What's the point of it? I said, you know, I can tell you something really simple. If you're really doing validation, you want to somehow keep track of all the data that's coming through your API. And if something unusual in that data is happening, let's say, for instance, you're, you know, keeping track of how many times people log in to your website, right? So on a usual daily basis, let's say once or twice. And all of a sudden, there's 50 times someone logged into their homepage or their web page. That will raise an alert. You might send an email to this user and say, you might want to change your password. It seems that there is an unusual activity on your account. You can use it in so many different things. And that's just one algorithm. There are so many of them out there that do a lot of different things. I really highly recommend that you take a look at it. I'm going to put some links in the description for this video. I'm going to obviously push that code to GitHub so you can take advantage of it and learn from it and hopefully run it locally and see what you can do with it. And please feel free to ask questions. I have the comment in the comment section. Thank you so much for watching, and don't forget to like and subscribe. See you in another video. Thank you.